everybody, welcome to my video tutorial all about physics. So for today's video, we will be solving some problems that is related to electricity and currents. So for today's video, I'm gonna teach you about the Kirchoff's rule. And gladly, I have a great teacher who teaches me well in solving this kind of particular problems that includes Kirchoff's rule. Okay, so we have a problem here, a electric current flowing to different circuits. We have some batteries or supply batteries or sources of electricity. So I'm gonna show you the problem. So guys, this is the problem. We have R1, which is 2 ohms, and R2 10 ohms, R3 6 ohms, and R4 8 ohms. And we have lastly R5 2 ohms. And we have supplies of electricity, which here 6 volts and 3 volts. So in order to solve that, we have to apply the Kirchoff's rule, the rule of electric currents. For us to be able to solve that particular problem, we must first identify the flow of electricity or current in that particular circuit. So we will be using a clockwise current. And after you chose a current, you must now choose which loop are you going to solve. It's either loop 1, loop 2, or loop 3, because we have 2 boxes here. So loop 1 from the right and loop 1 from loop 1 from the left and loop 2 from the right, and loop 3 would be the whole loop of this, including loop 1 and loop 2. You're not gonna include the current between them, but you would go around the circuit. That would be loop 3. But we're gonna choose loop 1 and loop 2 only. But even if you choose it's either loop 2 or loop 3 or loop 1 or loop 3, the outcome would be the same. So we already have our first formula, which is I1 plus I2 minus I3 is equals to 0. This is very analytical because, as you see, I1 is going this way and I2 is going that way, and the going to the middle would be I3. So that is how we get our formula. It is according to the Kirchoff's rule, which is the loop. I1 plus I2 is equals minus I3 is equal to 0. So moving on to our next formula that we formulated is using the loop rule on loops 1 and 2. So we have I3 R3, which is we found here because we use the clockwise current. So our current will be going clockwise. So we first go here. So we found I3 R3. So it's positive because it's going against our current. You see the arrow of I3 is going up and our current is going the opposite way. So that is why it is positive. Then the next one would be I1 R4. We have this one. All of this area here, follows I1. All of our area here will only follow I1 because I1 is going this way. So this I1, this is I1, and this is I1. So our current is going clockwise, and our I1 is going to the opposite of our current. So anything that would meet the current would be positive. So we have our I1 R4 positive because I1 once again is going against our electric current. So we have here I1R4. The next one will be I1R5. You see that? I1R5. You see here? There's all of this area would be I1 and I1. So we have I1R5. And our battery or the source of our electricity is 6 volts. So we put here 6 volts. It's negative because the long one here is positive and the short one is negative. So the sign follows like positive to negative is negative. So we will just substitute the r's of our equation. 6, 8, and 12, and we will combine those r's who have the same values, like 8I1 and 12I1. That would equate to 20I1 plus 6I3, and transpose 6 volts to the right side of the equation. So it's negative, so if you transpose it to the other side of the equation, it will turn into a positive, so that is equal to positive 6. So here is our loop 2. Negative I2R1 minus 3 volts minus I2R2 minus I3 minus I3R3. So we derive that from here. I2R1, so it's going along with the flow of our current, which is clockwise. So it's negative. That is why it is negative, because it's going along our electric current. So that is why it is negative. We put it here negative. So we go through a battery which is 3 volts here. We stated it here, 3 volts, and followed by R2, and this is still I2. The current here is still I2. I2 flows here, so that is why I2 R2, and then if we go inside, I2 and R1 are not included anymore, so it would be I3, so that is what we wrote here, I3R3. So we're just gonna substitute the formulas of our r's, the -2, -10, and -6 goes to 0. Then we will join the same. We will group those have the same values, -2 and -10 I2, so they are both I2. Just gonna group them together. It would equate to -12 I2, and then 6 I3 equals to 3. So here, that is how we derive our second equation. Our first equation, 2I1 plus 6I3 is equal to 6. 12I2 minus 6I3 is equal to 3. So here our derived formulas based on our circuit. And the next thing that we will do is to manipulate those in order to get I1, I2, and I3. So this time we will use equation 2 for us to be able to solve for I1. So here is our equation 2. 20I1 plus 6I3 is equal to 6. Okay, so we need to solve for I1. So we need to come up with an equation that goes something like I1 is equal to choo-choo. So in order to get that, we must first transpose the 6I3 to the other side of the equation, so that 20I1 will be left alone at the left side of the equation. So here is the outcome. 20I1 is equal to 6 minus 6I3, since it is positive on the left side, so when you transpose it to the right side, it will turn into negative. Okay, so 20i1 is equal to 6 minus 6i3. So we need i1. So for us to be able to cancel out 20, we must divide i1 to 20. So as the other side, so that the equation would obtain balance. We need balance in the universe. Sure. So we need to divide it by 20, then so that 20 would be cancelled. So this would be our equation for our I1. So I1 is equal to 6 minus 6i3 over 20. So we already have an equation for I1. The next thing that we would do is to solve something for I2. So in order for us to solve for I2, we need to use the equation number 3. Our equation number 3 is negative 12i2 minus 6i3 is equal to 3. What we're going to do here is the same as what we do in solving I1. So transpose negative 6i3 to the right side of the equation, so that negative 12i2 would be left alone on the left side of the equation. So it goes like this. Negative 12i2 equals 3 plus 6i3. In order to get i2 and eliminate 12, we must divide both of the we must divide the equation left and right side by 12. Again, in order to obtain balance. Divided by negative 12 and divided by negative 12. So the equation that we've derived is I2 is equal to 3 plus 6i3 divided by negative 12. And now we will substitute those formula that we've derived in the equation number 1 in order to obtain I3. So here is our equation number 1. I1 plus I2 minus I3 is equal to 0. So we already solved for I1 and I2. So our I1 is 6 minus 6i3 over 20 plus our I2 is 3 plus 6i3 divided by 12. So they have different denominators. So the next step would be get the common denominators of the two. So we must divide both of the equation according to their denominators. So to transform 20 into something that is similar to the other side, we must multiply this equation by 12. So as the other side. But this time we will use 20 because the denominator here is 20. So we must multiply this equation by 20. No, in order for them to have a same denominator. So as I3, we must multiply everything here accordingly to their denominators. So I3 multiplied by negative 12 and 20, negative 12 and 20. So we will get this, we will arrive to this equation. Negative 72 plus I3 all over negative 240 plus 60 plus 120 I3 over negative 240 minus I3 negative I4 over 240 is equal to 0. Okay, so since they have the same denominators, so we can eliminate those denominators already. So for us to arrive this formula, this equation I mean. So negative 72 plus 72 I3 plus mind the signs. We must take into account the signs. So 6 positive plus positive equals positive. So positive 60 plus 120 I3 plus 240. So it is positive 240 I3 because negative I3 multiplied by negative 240. So negative plus negative is equal to positive according to the law of integers. So we will arrive to this equation. So we will group those I3s and isolate them. 72 plus 120 plus 240 and move out the I3. Then we have negative 12 because 60 there plus negative 72 there is equal to negative 12 equal to 0. So we will add those numbers up inside the parenthesis, and 72 plus 120 plus 240 is equal to 432 I3 because all of them are I3. Equal to positive 12. It turns into positive now because as we transpose a number, the sign would be changed if we transpose that particular number to the other side of the equation. So it is now positive 12, and our aim here is to get I3. So for us to eliminate 432, divide both sides of the equation by 432. So 432 I3 divided by 432 I3 cancel out 432 equal to 12 over 432. So our I3 would be 0.028 amps. So we already have no I3, so we can get I1 and I2. And now to get I1 and I2, we will use the quantity that we get from I3. So we all know that I1 is equals to 6 minus 6 I3. So we already have I3, which is the value is 0.028. So 6 minus 6 multiplied by 0.028 divided by 20 is equal to 0.29 amps. Same as I2. All we need is to substitute the value that we get from I3. So 3 plus 6 I3 divided by negative 12. So 3 plus 6 multiplied by 0.028 divided by negative 12 is equal to negative 0.26 amps. So that's it. I hope you enjoyed watching and I hope you learned something. This would be the end of my video tutorial. Thank you for participating and spending your little bit of time with